The board's here. Someone say anything in the chat. Chat, you're killing me. Can you explain the pigeonhole principle? Sure. I hate pigeons. I'm gonna be so honest. I hate pigeons so much. When I was in Niagara Falls, one shat on my shoe. Like I was walking and it shat right on my shoe. Ever since then, ever since then, I fucking hate pigeons.
Stay up.
Oh God, this is being recorded. I am gonna be screwed. Oh, what do you want to go over? Pigeonhole.
Principle, right?
The whole idea of the pigeonhole principle is if you have right. I hate pigeons. If I have K containers, right? So this is a pigeonhole principle. There's also did I spell pigeon wrong?
There's no D.
There's no D. There's no D in pigeon. Pigeon. So if I have K containers, right? So K containers, and I have at least if I have greater than or equal to K plus one objects.
Okay, so if you had like two mortars, it's not gonna work.
So put into
like
K containers.
that's like you have to write like reverse functions, and then you're gonna.
Then there has to be at least one container
Yeah, that's
with more than one object.
like reverse, and then there's like reverse. Yeah. So reverse.
I think there's a generalized one for it that if you have, is it
It's not gonna create reverse.
roof of n over k, right?
That's like your
Generalized pigeonhole. Which one's generalized pigeonhole? If you have n objects, k containers, that means there's going to be at least one container with okay. This is like generalized pigeonhole. I spoke pigeon right this time.
I'd say
If I have n objects and k containers, right? Then at least one container. At least one can. I can't spell for my life. I also research. Container has the roof of n over k objects. Right? So an example of a question you're going to see, or at least I saw, is this one is the one you use. Okay, so this is the principle used for proofs, right? So this is like the one you use for proofs, right? So if you want to prove something, you usually use this product proof. This is if you have like numerical. So this is like you're going to have like numerical questions, right? So let's do an example of a numerical, right? So we know there's 365 days in a year. How many numbers? That's a big number. I've learned one thing from CS is that CS students can't do math. There's 7 days in a week, right? How many people must I have? And say I'm inviting people to like the learning commons, to like a bunch of people in the review session. How many people?
Yeah, I was with calling
To ensure that there's at least 3 people who share a birthday on the same day. Right? This is a classic example. 7 days. How many people should I invite to a review session to ensure that at least 3 of them have a birthday on the same day? Right? So that's where we use this formula. This is how I usually do it. 7 has to equal roof. No, sorry. This is not 7. This is our K. This is our 7. This is our K because there's 7 containers, one for each day. We have to find the n such that we get 3. N over K. N over K. N over 7. Sorry. No. So this is what I'm gonna do. I'm gonna subtract one from this side first, and that will get rid of the roof, right? Subtract one, I get 2, gets rid of the roof, we get n over 7, right? And then what I'm gonna do, I'm gonna solve for 7, solve for n. So again, n is equal to 14, and I'm gonna add back that one. I think that strategy usually works. The only difficult thing is trying to get rid of the roof function. But once you get rid of it, I subtract 1 from here. You get 2. 2 times 7, 14. 14 plus 1, 15. And if you want to check it, what does that mean? That means 15 over 7. The roof of that. 15 divided by 7 is like 2 point something. The roof of 2 point something, you always round up, is 3. And it makes sense. If I have 15 days, worst case is the first 14 people. I keep drawing on myself. The first, the worst case, if you have 14 days, is that 2 people go into each day equally. So I mean 7 days, 2 people per day. Once you have the 15th person, it has to go in one of the 7 days. You get 3. So that's how you ensure it. Is everyone okay with that? Do you want me to do one more example of this? This is a generalized pigeonhole. If you're gonna get like a math question. Oh, sorry. Can you explain this problem? How many students must be in a room to ensure that at least 2 are assigned the same grade if a grade is a number between 0 and 100? Fine. Beep, 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 beep. I'm sorry to everyone at the Learning Commons. I'm a very loud guy. I get it from my mother. I'm being so serious. My dad's a quiet type. I like your glasses. They're very nice. Okay. Like this laughing. Oh, say hi to Mike. Say hi to Mike. No, he's leaving. Huh? Do you want to do it? Okay. I thought you were studying.
I am studying.
At least 2. So how many grades are there? 0 through 100, right? That means how many total grades there are? There's a total of 101 grades. Mm-hmm. Okay. And we want to get the number of students. So this is our K. It's our K containers. K containers. Think about each grade having its own container, right? So this is for 0, 1, up until 100, and you put a student in each container, right? That's how I like to think about it, visualize it. So we want 2 students to have the same grade. So we want to find this. N over K. Oh, I'm sorry. K is our 101. K is a 101. Okay. How do I do this? I want to get rid of the roof function. So what do I do first? I subtract 1. Because roof always rounds up. So N over 101 is 1. Right? Solve for N times 101 on each side. 101 times 1. That means we have N is 101. But remember, we subtracted 1 in the beginning. It's 1. So I got to add it back on. So that means if I have 102 students, then there has to be 2 students that have the same grade if the grades are from 0 to 100. And this is another example of the generalized pigeonhole principle. Does that make sense? Jensen, the one who asked, and anyone else who's here? Everybody. Sounds good. And this is more likely a type of question you're gonna get. The first question that we got, I think that was like a bit overkill. I doubt you're gonna get that on the exam. Maybe it's gonna be like a high point question. You could try it, but this is a more pigeonhole-y question. Mm. Generalized pigeonhole principle is just this, right? Using this formula. The pigeonhole principle is just the idea. If I have more objects to put into less containers, then at least one container is going to have multiple objects. Let's explain it one more time. Can I erase this? Is everyone okay with it? You want to take a screenshot? Go ahead. Okay, we're good.
Yeah.
Okie dokie. Let's do all this one more time. Expected value variance. We'll do that. We'll do that next. That's more probability. I have my own way of doing that. I like doing expected value variance. Okay. So generalize. No, not generalize. Pigeonhole principle. Pigeon is spelled with
All with the final.
and correct me if I'm wrong. This is just saying if I have K containers. Oh, I'm putting parentheses on the camera. I have K containers and more than K objects to put objects, then there has to be at least one container. Let me put at least. Let me actually write out at least. My back is hurting. At least one container, more than one object. Whoa! Where'd you come from? Where are you? This is general. This is not general. This is the pigeonhole principle. Just this.
We have no size.
Huh?
Right. In general, you say like instead of greater than K, you can have K plus one objects. But the idea is K plus one objects, K containers. There has to be one container with more than one object. Or in the idea of pigeons, if there's K holes, you got little pigeons. Those are pigeons. We got K plus one pigeons. There has to be one hole that has more than one pigeon. That's the whole idea of the pigeonhole principle. And now generalize is instead of just asking for K plus one, what if I had n objects, right? If I have n objects, then the generalized. Can everyone see the top and bottom? Yeah. Generalize says if I have n objects. No, Mac left us. Oh, never mind, he's here. N objects and K containers, then there has to be at least one container. One container with roof of n over K objects. All right, so it's generalizing this for instead of just K plus one or greater than K for any n objects. N objects, K containers, one container has, at least one container has n over K, the roof of n over K objects. Is that calculus? Mohammed, you want a good marker?
Bro, like what happened?
See if it works. Is everyone okay? Is everyone okay with these principles? If they are, I might move on to expected value and variance. Can you explain this formula? N over K. Is that roof of n over K?
It's like you just, okay, so just put a final statement. You just have the final caption.
Oh. R minus K. Well, I need to erase that. I can just switch it. Whoa. We've evolved, Chad. We've evolved. Evolution is silly man right in front of your eyes. So correct me if I'm wrong. This is what your formula is saying. R minus 1 equals n.
It's explaining the bounds, right? The bounds of the ceiling function.
What do you mean by the bounds? Huh?
Where's that admissions office?
What admissions office? We have an admissions office? Jefferson Hall. Biddy. Jefferson Hall, first floor, not first floor, second. Okay. R is the minimum number of objects that appear in the box. Oh, is that what we use? I think that's what we use, right? Oh, yeah, that is what we use, right? This is what we did, right? So R is a minimum. We want this to be R, right? So then what do? What we drop the roof, we subtract one, right? We multiply by K on both sides. Right, so K times R minus one, and then I add one. Has to equal K times R minus one plus one. That's technically the formula we did in the beginning. I just like generalized it. So once again, we have an example. I want to find the number of, let's do the example with the days, the grades and the thing. K is 101 for 101 possible grades, 0 through 100. R is we want, say instead of two, let's say three people. We want three people to have the same grade. So we want to find the number of people. Okay, so then is it going to be N over 101 is greater than 3, right? Subtract 1, that drops the root. Multiply both sides by 101, so we got N is greater than 102, right? When we add 1, right? So this is this step, this step, this step, and this step is we add 1, N has to be 203. I subtracted 1 to initially get rid of the roof function. Right? Because that's the function that's annoying us. The roof. So by subtracting 1 here, we get rid of the roof function, and then we just add 1 to get like balance it out. Okay. All right. Ria, do you have a specific question that you want to tackle, or do you want me to explain expected value and variance? Counting. Tree probability. Explain in all caps. What? Whoa. Do you have to follow that formula in an exam because GPT explains it much easier way? If you want to follow GPT, if the way ChatGPT explains it is easier, by all means, go for it. But like this is like a general formula, so up to you. Probability theory. To Ria, explain what? Explain like the idea of it or how to get it. Let me see probability theory. What section is this? Oh, expected value and variance. Let me explain it, but
Yo, that was the worst one because it's like you miss something.
Probability theory.
huh?
Probably start with probability theory, which is that expected value variance.
Yeah. Can you take it? I'm gonna stretch real quick. Take it for like 5 minutes. Take it for like 5 minutes. Oh my god, my back. Oh god.
Do you still need this part? I'm gonna reset. Actually, I'll turn the board around.
My beautiful work.
It's gone. There's one question you gotta skip.
Ask enter the waiting room. You're admitted.
So probability theory. Let's look at it.
Wait. This one. Is this 0 1 start? Or I mean, you're done. And then this is kind of.
Actually, okay. Probability theory. So, starting off with probability theory, let's say you have some events and you want to want to figure out the chances of
Final, I would.
these things occurring. So let's say I have a coin flip.
First thing.
Let's say I have a coin flip. In my coin flip, the chances of it coming up heads is 1/2. The chance of it coming up tails is also 1/2. And these are the only possibilities. If you add up all your probabilities,
100 points or 100 minutes.
you add them all up, they should always be equal to 1.
30 point questions.
Oh, so that's like a 10. That's like.
Let's see.
But you still need 6 points. I mean 6.
Yeah, they should always be equal to 1. Let's see.
No, yeah, 100. Shit, it is final. You have to
Bro, she dragged it.
she gives you a minute per point.
You also have
For the final, so 100.
you also have the chances of something occurring. Let's say, or the chances of something occurring given that you want the other thing happening. Yes, sorry, I'm a little disorganized. You also have conditional probability, which is what are your chances of something happening given something else has already happened.
I love conditional probability.
Okay, so conditional probability, let's say I want the chance that it'll rain today, given that it already rained yesterday. So let's say E is my chances of rain yesterday.
Back in 5 minutes.
And F is oh wait, E chance of rain today, because it hasn't happened yet. Chance of rain tomorrow. So the notation for this is what is the probability of F given E? Or I could say probability of E. Well, it wouldn't work in this situation. So what's the probability that F is going to occur given the chances of E occurring? So you have a formula for this, which is the probability of this is equal to probability of E intersect F over the probability of F of E in this case. So I'll show this with an example first. Let's say I'll try to solve a problem in the textbook.
Yeah, just like
gotta find one. Okay. What is the probability
spring 2020.
choices of the
So like something
she just given me 2 times as three.
this test.
Well, then the probability that 4 appears. Yeah, I'm trying to find a problem that uses this.
Oh, final sheet. Yeah. But then you probably are gonna choose the easier questions. Yeah, that's true. But they have serious. This is a 3 like legal 3. This is the same reason. See how? I think I remember this. What is it? What is it? Let's see what.
Oh, here it is. What is the conditional probability that exactly 4 heads appear when a fair coin is flipped 5 times? Given that the first flip came up heads. So let me just copy that into the chat to show that that's what I'm doing.
So like this one, you can't even have a pumping.
Okay. So for this one, the first thing we want to do is write down the probabilities of each thing happening. So let's say, okay, so there are 5
You're like
in total. So there are going to be 5 events. The chances that the first one will come up heads is going to be 1/2. So let's say H1 is equal to 1/2. So since it's asking what are the chances of you getting exactly 4 heads, if the first flip came up heads, it's like what's the chance of these things happening given that the first thing came up heads. So
Kathy, how are we holding the fort?
uh
I didn't get any birthday cake for us. I'm sorry.
so the chances now of having exactly 4 heads appear. Yeah, for those 4 flips is you have so if you have 4 flips, 1, 2, 3, 4, each one has a 1/2 chance of coming up heads. So you multiply these and you should get 1/16. So this is a chance of you getting heads 4 times. So now we want to put this all together. So what are the chances of both of these things happening at the same time? That would be 116 times 1/2, because if we had the first thing come up heads
Isn't this
and the
gonna be
last 4 come up
because exactly 4 heads means 4, you have to choose 5 coins, 4 to be head.
okay.
It's 116, yes, that's fair. It's like
It is 116. Yeah.
it's 116, but the idea is 5 choose 4. Yeah, 5 or 16. 4 or 16.
Or 16?
Because we have 4 heads, right? I'm not gonna write. Okay, maybe this helps you, right? We gotta have head, tail, head, tail, head. You see what I'm saying?
Anything
Head, tail, head, tail, head, tail. Oh,
No,
given
not that one. Not that one.
given the first one is head. So it's 4. And the probability that the first one is head is traditional probability that exactly 4 heads appear when the fair coin flips, given that okay, first game flips. Okay. No, it's fine. I love probabilities. This is my kid. Kathy has done a really well job, but for conditional probability, in general, our formula is probability of A given B. So this is A given B is equal to the probability of A and B over the probability of B. Right? So what does this mean? A is that exactly 4 heads appear. This is exactly 4 heads.
Is this greater than 3?
4 heads. B, given that the first flip came up heads. First.
And okay. So the moment, okay.
Right?
Let's say there's only 2 heads, right? Okay, that's not regular versus thing. But if it's 3 or more, then
so probability B, what's the probability that the first coin is a head? That's 1/2. Right? A and B, what is the probability that I get exactly 4 heads and the first one is a head? Well, we just saw the 4 cases. This is 4 over the total number of coin flips, which is 32.
Yeah, because these are not
4 over 32, right? Wonderful. All right, so this is 4 ways to total coin flips. Total ways to get 5 coins, right? And there's 4 ways. We drew out the 4 ways. All right, 4 ways. So now let's plug this in. 4 over 32 over 1/2. Keep, change, flip. Keep, change, flip. 2 over 32, that's the same thing as, I take out a 2 from here, I get 16. 4 over 16, that's 1/4. So there's a 1/4 chance that I have exactly 4 heads, given the first one is a head. Is everyone okay with that? This is the whole idea of conditional probability. This is Bayes' rule. Any questions? Any questions at all? Thank you, Kathy, again for taking over while I left. Had to run to a birthday party real quick, chat. But I'm back here. How did I get 4 over 32 again? So how many ways can I? Okay, if I have 5 coins to flip, right? 1, 2, 3, 4, 5. Each coin has a 1/2 probability. So 1/2, 1/2, half, 1/2, 1/2, 2, 4, 6, 8. I'm stupid. It's not 32. It's 16. 2 to the 5th is 16. Or 5th? No, 32. I'm bugging. 2, 4, 8, 16, 32. It is 32. So this is equal to 1 over 2 to the 5th. 2 to the 5th is 32. Right? That's the total number of coin flips you could get. Because each coin has 2 possibilities. 4 ways, well, you could either do this like binomially, or you just draw each method right here. So we got head, 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 tail, head, 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 tail, head, 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 tail, head, 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 tail, head, head, head. Remember, this is the first one is a head, because this is and. 4 heads, and the first one is a head. So we can't have tail, head, 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 head. We don't have this. We have these 4. So there's 4 here. 32 possible flips. 4 over 32. How do I get 1/2 for each flip? When I flip a coin, what's the probability that I get a head? There you go.
like word problems.
Any other questions about this?
There's but like when it's like make your
How do I find if an event is independent? Independence. That's the probability of A and B is equal to the probability of A times the probability of B. No, that's just it's independent. There's a formula for it. I forgot. The probability of an event is independent. This is event A. This is event B. So this is A, B independent. So the probability of A and B. Yeah, here's the formula, I think. If this is the formula we use to see if 2 events are independent. So if the probability of A and B is equal to the probability of A times the probability of B, then they're independent. All right, so if you wanted to see it like a bit graphically, you have 2 independent events because there's no overlap. So I think this is probability that I choose a specific shirt. This is a probability that I choose a specific shoe, right? What shirt I choose doesn't impact what shoe I choose? They're independent. So the probability that I choose a specific shirt and a specific shoe is like equal to the probability that I choose that shirt and times the probability that I choose that shoe. So you could do this math, and I think this is the formula. If you're given A and B, if that is equal to the probability of A times the probability of B, then the 2 events are independent. Otherwise, they're not. And I see that. Does that answer your question? Hopefully it does. I think you posted a question here as well. E. All right. E expected back some RPR. Okay. 1, F is the event that a bit string contains an even number of ones.
Yeah, I skipped them, yeah, I went, I was like, yo, like, maybe like.
Okay. This is an example. The probability, suppose E is an event that a randomly generated bit string of length 4 begins with a 1, and F is the event that this bit string contains an even number of ones. Length 4, okay. Are E and F independent if the 16 bit strings of length 4 are equally likely? Okay, let's first find the probability of E. No, not E, F. I don't know why they didn't. Okay, E. So this is the probability that it begins with a 1.
That one, like, maybe.
1.
And then, like, which string? Like, you just care about the A's, the I's.
So what is the probability? Well, this is 1/2, right? Could either have a 0 or a 1 for the first bit. There you go. And the probability of F is the event that this bit string contains an even number of ones. F. I'm sorry, I didn't mean to write that big.
G, what's G again?
G? 4 choose 0, 4 choose 2. Yeah. That's over 16 total possible strings. We have 4 of them. We could choose 0 to be 1, right? Even. Plus 4 of them, choose 2 to be 1. And plus 4 of them, choose 4 to be 1. Right? So 4 choose 0 is just 1. 4 choose 4 is just 1. 4 choose 2, 4 factorial over 2 factorial, 2 factorial. So that's 4 times 3 times 2 times 1 over 2 times 1 times 2 times 1. This goes away. Over here. This is 6. So this is going to be 8 over 16. 1 plus 6 plus 1 over 16. That's 1/2. This is 8. 8 over 16 is a half. Okay. So the probability that, holy shit, he is going into that group. So let's try and find the probability. So if they're independent, we know that probability of E and F has to equal 1/4. Why? Because that's probability of E times the probability of F. 1/4, 1/2 times a half equals 1/4. So this should be the case. Well, how do we find it? Either we're given it or we have to deduce it. So let's try this. What is the probability that,
First, write out like letters.
well, we could try and draw each string. Oh, this is easy because you gotta, okay, it's similar, right? Probability that E and F, let's try and draw out all possibilities. This is saying it begins with 1, and there's an even number of ones. Right? So what are the probabilities? If it begins with a 1, right? What does that mean? Can it have 0 ones? If it begins with a 1, can it have 0 ones? No, so we can't do it in this case. So it has to either have 2 ones or 4.
It was like.
Sorry, I'm having a scare up with a quick competitor.
All the constants.
What do you want?
Do you want some more coffee? What are you doing? Are you teaching? Oh my god. Like, such a bad.
Review session. You want to say hi to Vidya, everyone? Say hi to Vidya.
What is it there? Oh, students.
Vidya says hi.
Okay, I'm doing all.
Okay. So it's either 2 ones or 4 ones. 4 ones, it's a easy case, right? 3, 4. Fine. Beautiful. 2. If the first one is 2, these last 3 numbers have to have at least one, have to have exactly one. So this is 3, choose 1. Not 3 divided by 1, 3, choose 1. 3, choose 1. There's 3, choose 1 is 3 factorial over 3 factorial, not factorial, n minus k factorial. 2 factorial, 1 factorial, 1 factorial goes away. There's 3 times 2 times 1 over 2 times 1 goes away, so that's 3. So there's 3 possible. Right?
For this example.
So that means so we have 1 here, 3 here, there's 4 possibilities. 4 total possibilities.
But
And how many total ways can we get it? Over 16.
you gotta fill in.
This is equal to 1/4. Right? Is 1/4 equal to 1/4? Yeah. We got the 1/4 we wanted. And that means this has to equal this. And thus, the probability that it begins with a 1 and the probability that it's an even number of ones are independent. They're independent events. Any questions? Does anyone have any questions? Let me know. Sounds good.
Yeah.
Can I over that one more time? Okay, let's go from the beginning. Probability of E is that it begins with a 1. Well, 0 or 1, there's 2 possibilities. Begins with a 1 is 1/2. Right? Okay. The probability of F is there an even number of ones. There's a total of 16 ways you can get, like the total of 16 strings are given that. There's 3 possibilities for even numbers. 0 ones, 2 ones, or 4 ones. 0 ones and 4 ones are easy. Those are just both 1. 4 possibilities, we need to choose 2 of ones. That's 4, choose 2. That ends up being 6. Right? So the total number of ways that we can get an even number of ones in a bit string of length 4 is 8 over 16, which is 1/2. Okay? So now, in order to prove that they're independent, we need to show this. The probability of E and F has to equal the probability of E times the probability of F. Well, they're both 1/2, so 1/2 times 1/2 is 1/4, right? So if we can show that the probability that you begin with a 1 and that it's even number of ones is also 1/4, then we're done. We're done with the proof. So how do we do that? We could either we could do some mathematical proof, or the simplest case in this scenario is that we could look at the cases. Well, what are the cases? So this has to be begins with a 1 and there's an even number of ones. So there's only two cases if that's the case. If you begin with a 1, you could either have 2 ones or 4 ones. There's no way you could have 0 ones if you already began with a 1. So 4 choose 4 is easy. 4 ones, we begin with a 1, that's one case. Boom. If we begin with a 1 and we need 1 more to do the 2 ones, that means in these 3 remaining bits, 0 and 1s, there has to be that exactly one of them has to be 1. So that's 3, choose 1. Right? 3, choose 1 is 3. Right? So that means there's 1 plus 3, 4 total possibilities. 4 possibilities over 16 total bit string lengths. And what do we have? We have 1/4. 4 over 16 is 1/4. And what does that mean? That's equal to what we initially saw. 1/4 is equal to 1/4, and thus both events are independent. Everyone okay with that? Everyone okay? If everyone's okay with that, we could do what Jinsun wants to do. That's the formula of expected x. That's just like the formula for expected value. We could do that real quick. Everyone okay? Okay. What did Kathy post? Oh, Kathy posted the formula. That's where the formula that Jinsun you posted, you asked about. That's where the formula comes from. That's how you calculate the expected value for anything, right? What is this? I have two of them, but in general, what is R? What is R? There's no R in here. Okay. If X is a random variable, probably the X is R, so that if X is a random variable and the probability that X equals R is a probability that P of X equals, okay, so that P of X equals R equals a sum for all S in the sample space such that X of S is R, P of S, then the expected value of X is equal to the P of X lower times R. X is a random variable, and P of X equals R is the probability that X equals R, so that probability of X equals R is the sum over all the sample space samples in S such that X of S is R, P of S, the probability of that, then probability of P of X times. I think that's just the same formula, but written differently. Instead of X, you have deviation. Oh, yeah, that's just the same thing. All right. It's the same formula, but like I think they just switched it up. Yeah. Trying to see. Expected value also expectation or mean sample space has to equal to P of S, X of S. Okay, fine. Values of X are in R. No. That those are.
R is the event.
Yeah.
So that's like the value that would come up. Where the events.
Yeah. So like if you roll a die, in this case, R is like the probability that R is like the event you roll a two or an even number. Right? If that makes sense. So in the equation you gave, the expected value of X is the probability that you get an even number times all the possible even numbers. The sum for that. Right? So it's gonna be R is 2, R is 4, R is 6, and then each probability, so that's 1, 6, 1, 6, 1, 6. I hope that helps. Yeah. It's a probability that X takes up a specific event or random value. And hopefully that helps a bit with the question about expectation. The whole idea of expectation is you take every single event, right? This is how I learned it in 241.
Because all you have to do is write it down from every volume, and that's from every series.
Right. So I'm trying to write left-handed right now. If I give you a table, right, and I give you some X, right, and tell you the probability of it, I can't write every left-handed. I can't get this little way. Right? This is event 1. X1 has a probability of P. I can't write. I'm sorry. I'm going back to right-handed. Used to be lefty, but not anymore. X1, you got X2, probability of X2, right? Keep going down. If you multiply, right? So if you have another column, X times P of X, you have X1 times P X1, right? X2 times P of X2 right? Keep going.
Meaning
The
that
sum, that's our expected value. Right? So if we have a die that has like if we have a die, let me use the example of the die. Yeah, I think that would be a good example. Someone said something in the chat.
because if this is what can we ever get? I don't know if you say it is zero.
What are the possible values when I roll a die? You get 1, 2, 3, 4, 5, 6. What are each of their probabilities? 1, 6, 1, 6, 1, 6, 1, 6, 1, 6, 1, 6.
I mean, it's like
What are their times that? So 1 times a 6, 1, 6, 2 times a 6, 2, 6, 3 times a 6, 3, 6, 4, 6, 5, 6, 6, 6, right? So then if I add them up, 1 plus 2 plus 3, 6, 10, 6, 10, 15, 21.
like it will always be this now. It'll be 4, 8, whatever.
This is about
So you
I'm doing right. 3, 6, 10, 15, 21. 21 over 6 is around a 3 point. Right, so that's our expected. So if I roll a die and say I roll for each number of here, I get a certain amount of money. So if I roll a 1, I get a $1. 2, I get $2. 3, I get $3. 4, I get $4, etc. Then the expected value is saying that if I play this game, my expected earning should be around $3.50. Right? That's just like expected. That's the whole idea of expected values. Would it be x equals 6? In that scenario, if it was like for a die, it would be this is R is 1, R is 2, R is 3, R is 4, R is 5, R is 6, right? So this would be the probability that R is 1, R is 2, or X is 1, 2, 3, 4, etc. These are the R's. Right, and these are the probabilities of R's. Probability that X is R, right?
All
Right.
you need to make is the template. And you create the template now.
If that helps.
Right. I'm better when it's like just make.
And variance, well, variance is then, this is why I like this table, because then this helps with variance. The formula for variance, that's E of x squared time minus E of x squared. So we know E of x is 3.5, right? Is E of x. Right? So if you E of x squared, well, you just multiply x times this. So it's x times, that's x squared. E of x, that's 1, 6, 4, 6.
Yeah.
3 times 3 is 9 over 6. 16 over 6. 5 times 25 over 6. 36 over 6. This would be 1, 4, 9, 16, 25, 36. 5, 14, 30, 55, 91. 1 plus 4 is 5, plus 9 is 6 is 14, plus 16 is 30, plus 25 is 55. 91 over 6. So if I want the variance, this is the variance of x. Right? So it's going to be E of x squared, which is 91 over 6, minus E of x squared, the expected squared. So this is minus 21 over 6 squared. This is going to be 21 squared over 6 squared. 21 squared is 441?
And we're saying the first symbol is 8.
If I got that correct, God, that is a raise. 21 squared is 441. 21 times 21. It is! Holy shit, I'm goated. I'm goated.
Should it? But like
91 over 6 minus 441 over 36.
this.
I am not gonna try. Oh,
Saying, okay, this is true, right? But at the same time, we don't really
91 times 6 minus 441 divided by 36. So the variance
It's like this. Like this
is 2.9.
Care about that? We just wonder about what this gets. Because that's
2.9.
check it out again.
And if you take the square root of this, so 2.9.
And that would be fine. Yeah. It was just
Square root.
that would be right. That is fine.
2.9169.
Oh yeah.
2.9167. Alright, so that's the standard deviation is about 1.7. So this is that standard deviation. You know, probably won't need this now. It's the square root of the variance. That's around 1.7. Right. So what is it saying? You're gonna see this more in 241. So I'm just gonna give a bit of a sneak peek. Have you ever seen like the bell curve, right? The expected is this, the mean value. This like the if you ever seen like IQ tests, that's the middle. That's expected.
+4.
And we use variance to get standard deviation. This variance is like saying how far we can be from the expected value, right? Standard deviation is like these actual like limits and distances. So this is gonna be if this is E of X, this is the average plus 1 standard deviation, this is the average minus 1 standard deviation. This is if you add 2, this is if you add subtract 2, etc. So that's how you get the same. That's the whole idea of variance. Variance is difference from the expected, and we get from the variance we can get the standard deviation. Is everyone okay with that? Does anyone have any other questions?
So like this, right? It's big. So like they're not
Any at all.
Yeah. So they're like apart and records. It can't keep selling. Yeah, like
Everyone okay?
no spans. I think you gotta be here, like you're like get rid of this. Yeah, dude. But also like non-adjacent. Yeah, like these
Everyone's
are
good?
non-adjacent. Like I think if these A's are together, then we could from there. But here we can't because it's span
Alright.
like this.
I think everyone's good.
Yeah,
If everyone's okay, if everyone's
segments.
chilling. Kathy, could you send the feedback form, please? Please fill out the feedback form. I must know how I must improve. But I think I'm gonna do one for your final as well. I'm not sure. I think that might be the. I might have to check that. If it's done 3 hour, I might have to reschedule it. But if you want someone else to do the final review, by all means, request it.
Yeah,
The linearity of expectations. What does that mean? What the?
you could because what happens?
What is that? Hold on.
Basically, like these need to be the same length, right? That's the
Mm-hmm.
if this is weird, this is weird. Okay. They basically were saying, hey, they don't long time they just spun together. Yeah. So what happens is okay, say y is simple.
Oh, that one. Linearity. So I think that's just a general formula for like expectations. I think there's one for. Let me stop this.
A or and then here you can say 0 yeah, like violates.
I'll do this one before I end real quick. Basically, if I have this, we have these formulas for E of AX plus B. This is equal to A E of X plus B. This is basically showing how like the expected value is like it's linear in that respect that you could if you make any changes to it, right? It's gonna apply to it like linearly. Whereas like say if we have the variance, right? The variance of AX plus B, this is A squared times the variance of X. This isn't a linear. The variance isn't linearly like show like you see it like any change we made to it, A times X plus B, the A is squared when you apply to it. All right, so this isn't linear. E of AX plus B is linear. So even if you have the expectation of multiple events, that's their individual expectations added up. Right? So expectation is linearly is like it applies linear rules. Variance doesn't, because you see how variance of ax plus b is a squared variance of x. So b is, you don't really matter. Right? So e of x plus b, you apply it linearly. You treat x as, that's e of x, that's the variable. Does that help? Does that make sense? Sounds good. All right. If everyone's good, any last questions before we bid adieu? Please do fill out the feedback form. As for the recording, I'm gonna try and bother Ming to try and get the recording today. No promises. He might get it by tomorrow, today or tomorrow. Your exam's tomorrow, I believe, right? It probably is tomorrow next week, but um either way, hopefully I'll get it by before your exam. So so for anyone who wasn't here, if you were here and you want to rewatch it, feel free. All right. Thank you guys. Thank you guys and girls. Anyone here? I appreciate your time. And for those of you who are actively participating in the chat, yeah, thank you. Thank you very much.